Hello everyone, welcome back. So till now we have learnt about the conditional statement in ESQL, and we have also seen about the uh, how we can create the field in the SQL, how we can set the field in ESQL, basic of and ESQL data type. Now let's learn about the comparison operator in ESQL. When talking about the comparison operator, we have the greater than, less than, greater than equal to, less than equal to, and not equal to. Also we have the like, is, in, and exist, and between. These all things are comes under the comparison operator. This is basically used to compare the field, as name suggests, comparison used to compare the field, and most of the case it returns boolean value. Okay, so we will be covering each one of them in detail, and with the debugging thinking, these all things, so you don't need to worry about that. Before going to each one of the thing in detail, I want to uh, tell you what are the just 1 minute. Okay, so what are what XML we are going to use, and what are the condition, this basic thing I want to explain you. Okay, so what I did, I created application, not comparison operator. To create application, you have to do file, new, and application. Give the application name as a comparison operator or anything. After that, I created a message flow. In message flow, I just use the MQ input node and MQ output node and the compute node. That's the simple flow till now I am using. In MQ input node, I just selected the queue name as a test2.in, and in output I have selected as a test2.out, and in parsing I am just parsing the XML message. Apart from XML, I am not parsing in the message. And on parsing timing, I'm just selected a complete, so that in case of any parsing or validation error happen, then I will see the in failure. Okay, so that's about the message flow. Okay, and apart from that, if you see the compute node, I has just written the code in advance, and I will be explaining each one of them in detail, and I will be showing you each one of the thing in debug mode. And to avoid expending some time or making the video longer, still video will be going to longer because lots of operator is there, but I have written this all thing in advance, so better to have I'm mostly focusing on more explanation thing rather than expending some time on the writing the code, because everyone can write the code, but the better if someone has a better understanding, then he can further uh, encounter and deal with the different situations. Okay, so let's first tell me what example I'm going to use in this, what input message, because here I'm going to send the input message, and after that I'm going to do some code logic for different situations. Okay, so what input message I am using for this comparison operator? The same message, if you remember, this is the only message till now I am using. Till now I am using this one message, where we have the student detail. Under student we have the student. Under that we have the name, roll number, class, marks, branch, and the student. So till now I am using this XML uh, for the all of the example. Okay, you can question me that why I am using the same XML, because mostly if you see most of the educator people use a different input message to show the different cases. I can use the same thing, But the problem is that when I will be using the different XML message for the every video, I, I will need to explain the each example, okay, and that will be a similar thing, okay. So but it will take more time, okay. So and if I will taking the same example for the all the most of the cases, then you will be having the better understanding that okay, this is the example, this example actually sits in your mind, so that will be helping, going to help you. So that's the reason I am selecting the same example. You can try with the different example, but if you have any, if you are encountering any issue, then you can feel free to reach out to me. I am okay to help you, okay. Now let me go to the what actually I am doing in this let me better to have spend some more time on the explaining the situations. Once you will be explain, you will get understanding, then it will be a better better understanding on the coding thing, okay. So this is the input message I am taking, where the we have the student detail as a parent tag. Under that we have the student as a child. Further, student has the five child, that is the name, roll number, class, marks, and the branch. So under student we have this thing, and under student detail we have a student, okay. When talking about the name, the name can be anything, okay. When talking about the roll number can be any number. When talking about the class, so I have defined the class till first year, second year, third year, fourth year, because I am selecting the branch as a engineering branch. The mostly engineering degree consists of 4 year: first year, second year, third year, and fourth year. So class can be a first year student, second year student, third year student, and fourth year student. The possible value I am going to use for the class is the first year, second year, third year, and fourth year. So the possible options for the class is the these four. Now marks can be anything between 1 to 100, because it can be a student can score either 1 marks or he can score 100 marks, okay. So marks can be if I am talking about the range of marks, the range of marks will be between 1 to 100. Now talking about the branch, I have selected this much a branch, okay. Branch can be many, but I am assuming that the college have only 5 branch, okay. First is the CAC, that is computer science engineering. Second is the information technology, that is IT. Third is the electrical engineering. Fourth is the mechanical engineering, and the fifth is the civil engineering, okay. So I am assuming that these are the 5 branch that is present in the college. And if I am talking, the electrical, mechanical, and civil are called the core branch, and the CS and IT are called the non-core branch, or you consider it is the IT branch usage it. So this concept I am also going to use in the further example, that these are called the core branch and these are called the non-core branch. Further, I am taking 3 cases. First case I am taking, if a student is scoring a marks, if a student is scoring a marks between 1 to 39, which is also in other word I can say that marks less than 40, then the result for a student will be the fail. And if a student is scoring a marks between 40 to 75, so and here 40 and 75 is inclusive, okay, so it will be included, okay. So you need to remember this point, okay. Here 40 and 75 for this case is inclusive, okay. So here I can write 76, okay. So if a student is scoring a marks between 1 to 39, or in other words I can say that marks less than 40, then he will get a result as a failed, and a output message will be printed like that. A result tag we are going to create, under that we are going to create a field status, under that we are going to create a field failed. So when a student is scoring a marks less than 40 or between, you can say that 1 to 39, then he will get a result status as a failed. If a student is scoring a marks from 40 to 75, or in other words I can say that marks greater than equal to 40 and less than equal to 75. So it is between 40 to 75, where 40 and 75 is inclusive, can be included. So in that case, a student will a message a student will be passed in the exam, and he will a output message we are going to get as a result. Under that we have the status and as a passed. In case of a student is scoring a marks between 76 and 200, where 76 and 100 is inclusive, so, or you can say that marks greater than 75, then he will get a distinction and in the subject, and we are going to see a output message as a result status as distinction. So in case marks less than 40, then a student will get a failed. If marks greater than 40 and less than greater than equal to 40 and less than equal to 75, then he will get as a passed, and if marks greater than 75, then he will get as a failed. Okay, so that thing you need to remember, that 76 to 100 is inclusive, 76 and 100 is inclusive, 40 to 75, 40 and 75 is inclusive. Okay, that's about the concept that we are going to use. Okay, the branch, class, pass, fail, distinction, these what are the conditions we are going to use. That's you need to understand. Okay, now let's understand a few more concepts. You know that here, if here we have the student detail, under student detail we have the student, and under student we have these 5 child, right? So initially when the message, once we are going to send a message to this MQ input, once I am going to send a message from RFC to this MQ input queue, then message will came here and a logical tree is going to create, and under the input root we have the 3 segment called, first is the property, second is the MQMD, and the third is the XMLNSC. So consider this is the input root, under that we have the XMLNSC, under that we have the student detail, under student detail we have the student, and under that we have this file field. Okay, so if I want to access this name, then what we can write, input root dot xmlnsc dot student detail dot student dot name. Okay, similarly if you want to access roll number, then you can write input root dot xmlnsc dot student detail dot student dot roll. Similarly for the other field, class, marks and branch, we can write dot class dot marks dot branch. Okay, but every time writing so much long line, it will basically complicated for us. Okay, so in that, to reduce our effort, what we prefer to declare a reference variable called, and declare a reference variable and point the field using the reference variable. So same thing we can write in other way. We can declare a reference variable inref. Okay, and we can declare a reference variable called inref, which is a type of reference variable, and it is pointing to this field. So it is now directly inref is pointing to this. So what is this? Input root dot xmlnsc dot student detail dot student. So now inref is directly pointing to this. So I can replace this all thing with the inref. So it will look like that. It is a similar thing, but we are declaring inref to input root dot xmlnsc dot student detail dot student. So we are now we are creating a variable inref, which is a reference type, and this variable inref is pointing to a student. So now this variable inref is directly pointing to student. So it is directly pointing to input root dot xmlnsc student detail dot student. So it is directly pointing to this. So with this much of field, instead of writing this much of field, we can directly replace this thing with the inref. Now this this all thing, because you can see input root dot xml dot student detail dot student, this all thing is referring is getting referred by this single variable at inref with the help of reference variable. So this all field can be replaced with the inref, so it will look like that. Further, now we have simplified our tree like that. Now if I want to access my name, then I can write inref dot name. If I want to access my roll number, then I can drive refer inref dot roll. If I want to access the my class, then I can write inref dot class. Similarly, inref dot marks and inref dot branch for accessing marks and branch. So now, wow, how you can imagine how this is getting simplified, because earlier if I want to access the name, then I have to write input root dot xml dot student detail dot student dot name. This much of long thing we need to write. Now we have the small word like that inref dot name. Okay, so that's basically reduce our effort, and the coding makes it smarter. Okay, so same thing here, what I am writing here basically we are using marks field, right? Because I am comparing the marks. Okay, so if you want to access the marks, then how we can write you can write using the inref dot marks. So you have the two options: either you can write input root dot xml dot student detail dot student dot name dot student dot marks. Okay, so this much thing you can write here. Okay, or if you can directly declare this field with the you can directly this field with the inref, and now you can write inref dot marks. So here same thing I am using inref dot marks. I am using to check what value I am providing in input root. Okay, what marks value I am providing in input root. Okay, so in this way we will check the marks from this input message. We will check these marks from this input message, and we are going to compare the field, and we are going to provide the logic, these all things. Okay, so I hope you this example you have understand well. So if I say that this is the input message I am going to use in this example, class wise I am taking going to year, and branch wise I am going to take a 5 branch. There are as per different situation I am going to print this in output. Okay, and these are the situations, and these are the actual input tree, but I will be referring this till student as a inref, so it will become like that, and I can directly access the field with the help of inref, these all things. Okay, now without expending the time so much, let's switch back to the our toolkit. So already explained this thing how basically I created this message flow. Now let's go into the compute node, and let's cover each one of the operator, and let's see in debug mode. Okay, before that let me comparison operator, this is right. Let me delete the bar file, because I will be showing you by creating the thing. Okay, so just 1 minute. Let me delete all the bar file. I don't want to keep anyone. Okay, all deleted. Okay, so this is the code. So what I'm doing now, let's go each one of the line. Okay, so when talking about the comparison operator, we have the greater than, less than, greater than equal to, less than equal to, and not equal to, between, not between, exist, not exist, singular operator, then in, not in, each, not each, or like. Just 1 minute. Okay, here it is not like is not, is not. Okay, is not, and like, not like. Okay, so this much of the logic comparison operator we are going to learn. First is this, second is this, third is this, fourth is this, fifth, sixth, seven, total 7 comparison operator. Let's learn the first comparison operator, that is the greater than, less than, greater than, less than, greater than, equal to, less than, equal to, and not equal to. These all five, six operator I have covered in the single example. Let me uncomment this example and act to explaining. Initially, what I am doing, I am just declaring a reference variable INREF that is directly pointing to a student. That's the same thing here. Directly I did. So now INREF, with the help of INREF, we can fill the access this field. Okay. Same thing I have written here. Now what I am doing, what I am checking here, I am applying three if I'm applying here nested if. If I say in the technical language it is nested if, or if I say in simple language, I am checking three if conditions. Three if conditions. Okay. The first I am checking if inref dot class is first year. So if is not first year. So if the class, this class value from the input message, let me switch back. Okay, here. So if this class value is not first year, so we will check the input message. In input message, if the class is not first year, because here it is called not equal to. So if class is not equal to first year, then it will check further if branch is equal to CSE. So here we are using CSE equal to. Okay, so this is the equal to operator. So if we are checking if branch is equal to CSE, then further it will check if INREF or marks is less than 40. So in case if marks is less than 40, then it will print as a failed. Else if marks is greater than equal to 40 and less than equal to 75, then it will print as a passed. And else if the marks greater than 75, then it will print as a distinction. So here we are using the all the operator. Here I am checking the not equal to. Here I am checking equal to, less than, greater than, greater than equal to, and less than equal to. So all the operator have been covered here. Okay. So again I want to explain, if the first condition I will check if class is not equal to first year. If class will be, if class will be second year, third year, fourth year, then it will go further inside. It will check again if branch is computer science engineering. If it is correct, then again further it will go inside that, and it will check the mass condition. So if this is only, this code is applied only for the student who is studying in second year, third year, and fourth year of computer science engineering branch. If a student learning apart from that any branch, so this will be not going to win. So this will be printing only result for the student who is learning in the second, third, fourth year, because first it is checking whether the class is second year, third year, fourth year. If it is fourth year, then it will check whether the branch is CSE. If it is yes, branch is CSE, then it will check the marks condition. Okay. If it is, if class is not second year, third year, fourth year, then it will terminate the loop and it will go outside with the blank message. Okay. So let me show these all thing in debug mode. Okay. So let me first create the bar file again. So it is the comparison. Let me select this and let me build and save the bar file. Okay. Now before that, I think I have the something deployed here, comparison with comparison. So let me delete the thing also. Okay. So I've deleted the application. Now let me again deploy the application. To deploy, just right click and deploy. So it has been deployed successfully. Now let me launch the debugger. So debugger has been launched. Now let me hit the flow. To hit the flow, first I need to open the RFH util. Let me open the two RFH util, one for the input queue, one for the output queue. Okay, so test2.in, that is the queue. If I can show you, so input queue for this message flow is test2.in, and for the output queue is test2.out. Okay, so this is the queue already selected, test2.in. Let me load the message. Before loading the message, that's the different case. Let me select the output queue. So output queue, again let me load the name, and here I will select the test2.out. Okay, okay, currently there is 3 message. Let me read the all message in output queue. Okay, now, okay, now let's understand the situation. Okay, so let's, as per the code, let's first send the situation like that. Let's me make this class as a second year. Okay, and branch as a CAC. So it will satisfy the first two condition. If you go here, class not equal to first year, that is correct. You can see class not equal to first year, class is second year, and branch is equal to CSE, so it is also satisfying this condition. And further it will check the marks. Currently I am sending the marks with the, let's set the marks with less than 40, first condition. I will be checking all condition every time. Okay, so let me marks 39. Okay, and let's select the condition. Okay, then let me put the message. So this time I have selected the message with class branch this and the marks less than 40. Okay, let me write the message. Okay, a message has been written, it came here. Let me go inside the compute node. You can see I just run the command, and with the help of that I have declared, I have just created a reference variable, and it will be under reference variable we have the name, roll number, class, marks, and branch. You can see the city is the similar thing that I have written here. If you see, it is a similar thing I have written here, inref.name, class, marks, branch. Further, if you want to access the name, you can write inref.name. If you want to access the role, you can write inref.role, and you can inref.class, inref.marks, and inref.branch to access this value. Okay, and these are the input value that you can see the same value in the input route. Okay, because inref is you can see the same value in the input route. Okay, so because inref is pointing directly to student, so directly I can write, instead of writing this whole thing, I can write directly inref and further under this value. Okay, so this thing already explained you. I don't want to spend so much time on this. You can currently see, you can see in output there is no field. Okay, so what I am writing here, first condition it is checking whether a class is not equal to first year. Okay, you can see class is not equal to first year. Okay, condition satisfy, it will go inside the first if block. So it go inside the first if block. Okay, you can see it came here. Again, for second condition it will check if inref dot branch is equal to CSE. So inref dot branch is equal to CSE. Okay, so it is satisfying the another second condition also. So it will go inside the second if else block. Okay, so it will further go inside here. Okay, so you can see it came here. So it first goes inside the first if block, second if block, now it came to the third if block. Okay, so it will check if inref dot marks is less than 40. Okay, so inref dot marks is less than 40. Yes, it is marks less than 40. So it will execute this line of the code, because if this condition is satisfying, then it will go inside this. Okay, it will return true. Okay, so you can see it came here. Currently if you see in output there is no field. Once it is this line of code is just going to execute, it is going to create a field. Already output route is there. Under output route it is going to create xml dot result dot status. Under that a field is going to set. Okay, so you can see, okay, our xml dot result dot status dot fields it is going to set. Okay, and same thing we are going to see in the output route, in the output queue. Okay, so once this line of the code has been executed, further it will not go into the further else if block, because here itself it is satisfied, so it will terminate out of if block. It will go out of if block. The first if block is ending here, second if block is ending here, sorry, a first if block is ending here, for the second if block is ending here, and the second block as a, and third if block is ending here. Okay, so if this will be line will be executed, this code is going to execute, so it will terminate from the indef block. If this is not going to satisfy, then it will be going to terminate from here, and if this is not going to satisfy, then it will be terminate from here. Okay, so we will check the condition according. Okay, so let me see the output queue. You can see the output queue, you will see as a field. Okay, you can see the field. Okay, right. So in this way we have checked how the less than works. Now let's try the other condition. Let's keep the marks now as a 50 or 40. Okay, so let me again hit the message flow. So I have selected the marks as a 40. Let me write to the queue. It came here. I have declared the INREF as a reference value. You can see the marks is currently 40. First condition, class is not equal to first year. Okay, current satisfying. It will go inside. Again, second condition it will check. Branch is equal to CSE. Yes, it is satisfying. And it will check first condition, if marks is less than 40, so it is not less than 40, because you can see it is equal to 40. So this condition is satisfied, it is greater than equal to 40, and it will directly came here. Okay, because if condition, if this will not satisfy, then further it will not go to each if else block. You may think like that, if this condition will be not satisfied, then it will further check this condition and then execute this one. Yes, it will do like that, but these all things happen in background, and this will check first this condition. If it is satisfying, then it will execute this line. If this is satisfying, then it will execute this line. So it will directly came here, because this condition is satisfying. It is because marks is greater than equal to 40 and less than equal to 75, so it is satisfying this condition. Okay, so you can see it directly came here, and it will print as a passed, and you can see the same in the output. You can see passed. Now if I will again send the marks with 50, I want to show you all possible cases. Okay, maybe it will be going to longer video, but let's enjoy the class. Okay, so if I will write here, and if I will go inside further, you can see it came here. First condition satisfied, second condition satisfied, further it came here, marks is greater 50. So you can see the marks satisfying this condition, it is greater than 40 and less than 75, greater than equal to 40 and less than 75. So it is between 40 and 75. Okay, so it directly came here, and it will print as a passed. So you can see, and same thing you will be seeing in the output queue. See. Okay, now let's browse the another condition. Suppose this time I am sending marks as a 75. Okay, so if I will again browse the queue and send a message, so just written the message, it came here, declare the NREF. You can see the marks is greater than 75. So first condition satisfied, class is not equal to first year. Second condition satisfied, class is branch is equal to CSE. Okay, it will check if the marks is less than 40, so it is not less than 40, so it will be condition lying the marks is 75, so it basically lie in this condition, marks greater than equal to 40 and less than equal to 75. So it will directly came here, You can observe this cursor because this cursor is moving. Okay, it directly came here, and you can see the after running this in the output past is going to print. So in output you can the field has been created with the result dot status dot past. Okay, and further you are going to get into output queue as a past. Okay, so you can see in output queue as a past. Okay, now let me try other condition. Okay, so let's try the distinction condition if marks is greater than 75, that is let's use the 76. Okay, so in that case let me open the file and let me write the message. This time message came to the compute here, and let's go inside the compute node, declare the inref as a reference variable. You can see marks is this time 76. First condition satisfy, marks class not equal to first year, that's correct. Branch is equal to CSE, that is also satisfied. It came here, it will check the marks. Okay, marks is less than 40, correct. That will be false, so it will not go into this e block. Further it will check else if condition. Okay, marks greater than equal to 40 and less than equal to 75, so it will also not satisfying. Marks is not between 40 and 75, so this block is also not going to execute, and it will not come here. Further it will check this else if condition. If marks greater than 75, yes, this condition is satisfying, so it will go inside this else if block. Okay, so directly it will came here and it will execute. Okay, so you can see directly it came here and it will execute this line, and after that you can see in output and a field has been created with the status value as a distinction, and this time in output key we are going to get a distinction. Okay, you can see. So we have checked the condition of the all condition of less than, greater than equal to, less than equal to. Okay, now let's check the condition first in not equal to. Okay, so if let's modify the branch as a some other branch, let's modify the branch as a electrical branch. Okay, so here this time the branch is not CSE. Okay, so let me hit the flow and to show you. Okay, so let me write the message came here. Let me go inside the compute node. You can see declared the inref. Currently it will check the first condition if class is not equal to first year, so it is satisfying because class is second year. It will go inside the first if block. Then again it will check the second if condition. Second if condition is if inref dot branch is equal to CSE. So inref dot branch is equal to CSE. So it is not satisfying the condition. So it will further not go inside this if block, and it will terminate this if block, and it will go outside the if block. So you can see it directly came to return true. It has not executed the any line of the code, and you can see currently in output there is nothing present. Okay, so here what we are checking, you can see here it is comparing the branch. If branch is CSE, then it will go further inside the if block. If branch will be not CSE, then it will terminate out of if block. So here we are writing if and end if condition. Okay, only if applying, not applying the if else condition. So only if condition we are applying. Okay, so here it is checking whether branch is CSE, so it is not CSE, so it will directly terminate from the if block and directly came return true. And output because as the code has not executed anything and we have not set it in output, so it will directly came output and blank message going to return, because currently in output there is no present, nothing is present. So if you see in the output, one message has been written but with the blank message. Okay, so in this way we can see how we can use the equal to operator. Now let's try with the another condition. Okay, this time let's keep this as a CSE itself, and but in branch let's use the first year. Okay, so this time I have selected the class as a first year. Okay, and this time I'm going to check the not equal to. Okay, condition. So selected the message, let me write to the queue. It came here. Now let's go inside the compute node and declare the inref as a reference variable. You can see field has been created. It will check the condition if inref dot class not equal to first year. Inref dot class not equal to first year. So this condition is satisfying because it is equal to first year. Okay. So it will directly, even the first if condition is not satisfying, so it will not further go here and it will terminate out of if block. Okay. So here we are checking if the class, how basically not equal to works. Okay. So it will first check the if condition. Here if condition is not satisfying because class should be not equal to first year, but here the class is first year, so it will terminate from the first if block and it will not print anything and blank message will be written to the output queue. You can see it directly came to return true, and you can see the blank message will be written. If I will browse the output queue, you can see the blank message because there is nothing printed to output route. Okay, no output tree has been created. Okay, so in this way we have explored the all situation like that, the how we can deal with the greater than, less than, greater than equal to, less than equal to, equal to, and the not equal to condition. Okay, so this operator has been completed. Okay, now let's move to other condition. Now let's deal with the between or not between. Let me uncomment this line further. So when talking about between and not between, it is similar to what we have written here, this line of code. It is similar to this thing. Same line of the code we can write into other way using the between. Okay, the same line of this code we are going to write into the other way with the help of between operator. Okay, so if I will talk about some definitions, so syntax for the between is we write first value, after that between operator and the minimum value and maximum value. So that's the syntax you need to just keep in mind: value, between, minimum value, and maximum value. And the most important point in between is, mostly we think like that between is not exclusive, because mainly we say that between 5 to 10, so mainly we consider like that 6, 7, 8, 9. We don't consider 5 and 10 in ideal scenario in the real type. Okay, but here in the ESQL it's different. Here if I am saying between in ESQL, so it means it is inclusive. If I am saying 5, between 5 and 10, it means 5 and 10 is included. So if I am saying 5 and between 5 and 10, so it is 5, 6, 7, 8, 9, 10. Okay, so that's the thing. The between ESQL is inclusive. It includes the boundary value in the comparison. Okay, so it includes the boundary like that 5 and 10. Okay, now let's go to the code. Okay, so if I am saying if inref dot marks, same thing, that's the marks here printed here. Okay, so if marks between 1 and 39, then print this as a failed. In output route, send as a failed. If marks between 40 and 75, then in output route create as a pass, create the field as a passed. And in else if marks not between 0 to 75, then it is distinction. So let's understand that this thing. Okay, what I am writing here, if inref dot marks, I consider this first syntax. Okay, here what is inref dot marks is the value, between is the between operator, minimum value is the first, and is the further and operator, and max value is the 39. Similar thing I have written to each one of them. Okay, now here if I have here first I am checking if inref dot marks between 1 and 39. So it is 1 and 39 is inclusive. So if someone is scoring 1 marks, then it is also going to include. If someone is scoring 39 marks, then this also going to include in this condition. Okay. So if marks is between 1 and 39, in other word, I can say like that, if marks is less than 40, then it will create a tree as a result dot status and set a value as a field. Else if this condition is not satisfied, then it will check further as a, if marks is between 40 and 75, so 40 is also included and 75 is included. Okay, so if marks is scoring 40 and greater than 40 and 75 and less than 75, then it will create a field as a output root and set a status as a passed. And in other word, I can say that this condition is a greater than equal to 40 and less than equal to 75. Okay, now if still this condition is satisfied, then it will check a container condition. If inref dot marks, so marks value not between 0 and 75. So if marks, or here I can also write, maybe a student can score a 0 marks also, so I can write here 0 also. There can be a possibility that a student can score a 0 marks. He can keep the paper as a blank, so teacher can score a 0 marks, but he cannot score a negative marks, because a student negative marks is not possible. So max possible is the 0 marks. Okay, in the exam. Okay, so can be 0 marks. Okay, so here 0 is also included. So if the marks not between 0 to 75, then it will print as a distinction. So here we are using not between 2. So here if you see here, I have used between, not between. Not between is opposite of between. So it is like that. If I said not between 0 to 75, it means it is greater than 75. Okay, so if I am saying not between 0 to 40, so it means greater than 40. In simple way, I can say that if someone is saying between 0 to 75, so it will 0 and 0 to 75, right, including 75 and 0. And if I will include not, so it will apart from that, so it will be like that, from 76 till 100. Okay, so here you can use you can see how we are using the not between operator. Okay, so if I am saying not between 0 to 75, it means it is greater than 75. So in that case it will be distinction. So let's try to see in this in debug mode. Okay, okay, let's try to see this in debug mode. Okay, so let me again build and save, because I did modification to code. So let me build and save the bar file, and let me deploy the code. So deployed successfully. Now this time we are not going to check any class on the and the branch. Only we are going to check the marks. So let's first print the marks. I am sending the first marks as a 39, because I want to show you how basically the between is including the boundary thing also. Okay, so that's the thing, I am selecting the boundary value. Okay, so first condition I am sending the marks is 39. So I just selected the right. Let me write to the queue. It came here. Switch to debug perspective. It came here. Declare the inref as a reference variable. You can see the in inref the currently marks is 39. It will check first condition, if inref dot marks between 0 to 39. Yes, it is 0 to 39, where 0 and 39 is included. So this line of code is going to execute, and we are going to see the field. So you can see this line of code executed in output root. It will field will be going to create as a field. You can see in output root it created as a field. Okay, and after that we are going to see in same thing in the output. If you see field. Okay, right. So in this way we have seen how basically we are working on the in operator. Now let's try the another marks. Suppose a student score a marks 0. So in that case what will happen? So let's again select them and let me again write. So it came here, it declared INREF as a reference variable, marks is 0. So again this condition is satisfying if marks is between 0 and 39 and 0 is also included, so it will come here and it will print as a failed. So you can see same thing in output. Okay, currently it is here, so let me complete the flow. So if you see the queue further, see it is failed. Okay, so and if I will further write any value between 0 to 40 39, so let's student scored a marks 25, so still we will see the failed. Okay, so I want to show you all possible cases. Okay, so if I will write the message to queue, you can see, and if I will go further to the compute node, and if I will, you can see the marks is currently 25, which is lying between this also, so it will print as a failed. So it will create a field as a failed. Okay, in output queue we are going to see as a failed. Okay, so let me in the browsing. Okay, so that's the first case. Now let's try with the another case. Okay, so let's send a marks 40 this time and let's see what is happening. So open. Okay, this is the output queue. So I just written the message, so it came here. Let's go inside the compute node, declare the INREF, and it came here. It will check whether it is between 0 to 39, so it is not 0 to 39, so this condition is not going to execute. Further it will check this condition, else if condition, if INREF dot marks between 40 and 75, so yes, here 40 and 75 is inclusive, so it will satisfy the condition and this line of code is going to execute. So you can see it directly came here, right? And after that a field output it is going to create with the real dot status as a past, and same thing we are going to see in the output queue also. Okay, similarly you can include the, if you see the higher value also, if I will, instead of I will send a marks as a 75, so if I will write here a 75, so it will go inside a compute node. It will check the first condition, it is not satisfying, so it will check this another condition, it is between 0 and 40 and 75, so you can see it is 75, so it will and 75 is inclusive, so it will execute this line of code and you can see the output as a past. Same thing you can see in the output as a past. Okay, now again if you want to execute a marks between that, you can execute, you can write, suppose I am sending a marks between 70, okay, between that. Okay, so if I will again write the queue, it will still print as a pass because it is between that condition. So let's me show you. You can see because it is between that and it will print as a pass. You will get as a pass. Okay, now let me last condition, if marks is greater than 75, so let me make this as 76. Okay, this time, and let's see what is happening. So right, this time we are going to, okay, I'm just writing, I'm writing to wrong queue, I written to output queue, just me clear that again, say let me write the input queue. So selected and just sent It came to debug mode. Let me go inside this, declare the INREF as a reference failover, and you can see currently the marks is 76. So it will check marks is between 0 to 29, so it will not satisfy condition, so it will not go here. Further it will check this condition, if marks is between 40 and 75, so it is also not satisfying, so it will not go here. Further it will check this condition, if marks not between 0 75, so if marks is not between 0 75, so it is satisfying because marks is not between 0 and 75, so it is greater than 75. Okay, so you can see directly it will come to this condition and it will execute this, and in output we are going to see as a distinction. So in output, if I will browse, you can see a distinction. Okay, so in this way we have seen all the between and not between operator in the ESQLs. Okay, now let's go to the other conditions. So if I will, let me comment this also, and okay, now let's go to the exist condition, and further let me uncomment this thing. Okay, and let me do the all the works. Okay, let me build a bar file, let me deploy the thing, then I will explain to you. Okay, it's done. Okay, now when talking about the exist okay, exist syntax for exist is the exist and the list expression. Okay, this operator returns a boolean value true or false after checking if a particular element exists in the message tree or in record. Okay, suppose suppose there is a table, and in table if you want to check a particular thing, so you can use the exist basically used to check if it will you can as name suggests exist, so it will check whether any element, whether any record is exist or not. If record will be exist, then it will return true. If record will not exist, then it will return false. So as the name suggests exist, so it will check if any record exists or not. If record will be exist, then it will return true. If record will not exist, then it will return false. Okay, so if you see this operator, so syntax you already know this thing. So this operator return boolean and true and false, already tell you, after checking if a particular element exists in a message tree or a record. So it will check whether a particular element exists or not. If it will exist, then it will return true. If it will not exist, then it will return false. It evaluates to true if the subquery return one or more row, or false if subquery returns no row. So it's saying that it's same thing, saying that if record, if as a result as a result of exist, if we will get one or more record, then it will true. If we will not get no record, then it will be false. This operator is useful for checking the presence of record in database. So already told you the most use of the exist is in table. When suppose we have a table, and in table if we want to search something, suppose in table I want to search something, some value, then we can use the exist. So we exist basically checks if this value exists, then do some like of coding, and if not exist, then do like some type like coding. So it basically used to search search a what I said, search a rows from the table in database. Suppose I currently don't have the database. If further when I am going to configure database, then I can show this condition. I will be showing this condition, so don't need to worry about that. But currently I don't have database configured, so I will be showing you normal example. So if suppose the most, already again I am saying, the most time we are using exist with the database. Basically if we'll check whether any row is returning, if any row is returning, then we will apply some condition. If no row will be returning, then we will apply some other condition. So it basically checks, it basically used to check if we are getting any row, if from a data table, if we are getting some row, then we will apply some logic as per the business logic. If we will not get any row, then it will be applying some other logic. Okay, so let's consider example. Suppose same example here. What I am checking, already you know that select operation, select syntax. I already told you how select works. Okay, so that's you don't need to surprise, but further there will be a separate session for the select. I will be explaining you, but for now let's understand the basic of select. Okay, so first I am checking if select R from a student where R as R, where R dot class is second year. Okay, so if this, we are checking if class is second year. Okay, and if any value, if any value is coming as a second year, then it will print this thing. Else if class is not second year, then it will print this thing. So I just written a simple query. It is saying that, it is checking that if this basically not applied to this can be applied to either only one field or it can be a many field. If there will be a record like that, suppose if there will be record like that with the handwritten record, that's not a problem. Okay, so in this I'm just showing 4. Okay, but it can be a 100 record, it can be 1,000 records, it doesn't matter. Suppose there is a list where 100 student is present. Okay, and we want to check, and the list has mix up value with the class first year, second year, third year, fourth year. Okay, so we want to, suppose there is a website, in other word, sir, there is a website where result has been published and the result is mixed up with the first year. In other word, let's understand, not the website. Suppose there is a database. In database we have the one column, one table as a result. In database we have it one table as a result, and that result basically tells the student that your result, what is your result, what is the marks you have scored, what is your name, these all things. Okay, but that table is not specific to any branch, any branch or any class. Okay, that's table basically mix up table. That table contains the result for the first year student also, that for the second year also, that for the third year also, that for the fourth year also. Okay, so we have a table name result. I'm just explaining you in a better way. Okay, so we have a table name result, consider like that. Okay, this is just I'm just consider like that for your better understanding. So we have a table name result. That table contains the result of all student of the particular college, whether it's the student can be a first year student or a second year student or a third year student or the fourth year student. And suppose a student wants to fetch, a student from the second year wants to check his result. So that's the condition will be applied for that. Okay, so here we are checking, here we are writing a code in such a manner, it will only fetch the result of the student of the second year only. So if the result table will contain the class as a second year, it will print the result for the second year. Else if class second year not found, if class second year not found in the table, then it will tell like a second year result will publish soon. So what it is doing, it is first checking in the table result that whether the any column has any column, any class column consider this all as a column, name, roll number, class, marks, branch. Okay, so it is checking whether class column contains the second year. If it contains the second year, it means there will be some result published for the second year. So what it is going to do, it will be collecting all result from second year and it will be publishing in output. Else if this condition will be not satisfied, then it will check further. If second year will not exist, suppose if there will be no column with the second year, then it will print in output as second year result will be published soon and please keep checking the college website for updates. Okay, that's a simple code I am writing where it is checking the database. If column contain the second year field, then it will print it will consolidate all the result for the second year and it will print in output. And if it will not contain second year, then it will print something hard coded value. So what I am doing here exist is checking whether any record is exist or not. If it is exist, then it is printing in output. Similarly here not exist. If here it is checking whether second year exist or not exist or not. If second year is not exist is opposite of exist. So it is checking if second year is not exist. If second year, if the class column doesn't contain second year, not exist, then it will print like that. Okay, so that's the simple thing I am writing. So here what I am writing here, select R from input root dot class dot student. You can see the student tag is repeating. If you see here, a student tag is repeating, so that's the reason I am using here the list expression. So whatever the tag repeating, you need to write here the list expression as R. So what is R? R is this thing till student. So under R we will have name, roll number, class we will get. Okay, we are checking R dot class. It is similar like that inref dot class. Okay, where what I am writing here, I am just writing this as R, and further with the help of R dot class I am just applying where condition. So it is just selecting from this table, from this XML message, it is selecting like that till what it is, input root dot xml dot student. From student it is till student, I am just selecting this as a R. Further with the help of R dot class, it is checking all the classes, and if it is finding it is second year, there is some second year value, then it is this condition is satisfying. Further I am just creating some field in output at result dot status dot student, and again this student tag is going to repeat. So I am just using the list expression further here. Again same thing, same code I am writing here, where I am just selecting R from this, and we are checking the class as second year. So whatever the value present for the second year, what are the value present from the second year from this list, I am just selecting the thing and just printing to and just sending to output as a in output root. Okay, so I am just creating a output root, this one, and what are the value present here, I am just setting in the student field and sending to output. Else if same thing I am written here, if second year not exist in the row, in the column, in the class field, in the this class field, I am in this message, if I am not getting second year any value, then in that case what I am doing, I will be printing this thing. Again I am creating a field in output root as a result dot status, and I am just hard coding this some value. Okay, so I hope you have got what I am actually want to explain. So let's see this in debug mode. Okay, so already deployed this all thing I have done. Let me write the message. So again let me modify this thing. So currently this first year, let me modify the something value. So this as a second year, and this as a again first year, let me this as a second year. So I just currently this contains the two first year and two second year. Okay, so first condition will be satisfied. Okay, so let me again write the message to the queue. So I just written the message, it came here, it gone to debug mode. Okay, so by mistake I did something. Let me, you can see in output same thing is coming, but I'm expecting, but I forget to go inside the compute node. So let me again write the message to queue. Right, just written the message. Let's go inside the compute node, declaring the inref, although it is not required, but I have not uncommented this, so it is not required for now. Okay, so once you can say it came here. Here what it is checking, exist if exist this record, then it will go in, it will execute this line. Else if this record will not exist, then it will, this line of code exists. So here we can, instead of writing this all line, I can write also as a else, if this will exist, else this condition. Okay, but further actually I want to show you how basically not exist works, so that's the reason I have written like that, not else if not exist. Okay, so here what I'm writing here, you can see select R, I am selecting R from input root dot accumulate student till a student. I am just pointing this as a R, and further with the help of R dot class I am selecting this as a student. So if I will execute this line, you can see currently first year it is showing. It will check in the second condition, it will check in the third condition. You can see currently it is found, it came here. You can see it checks the all condition, all four condition. It whatever the thing found it got it, because second year is found here in the record. You can see the second year, there is two second year. The first is this one second year, and there is this one second year. So it checks the condition, from this message, and it found that there are two records found in the this exist operation. So it directly came here under this block, because the exist is only used to return the true or false boolean. So this condition is satisfied, so it will return this. So here what is it is checking if any record exists or not. So you can see the class is equal to second year, and there is two field here second year. So it means the value is exist, so it will satisfy this condition. And what I am writing here, I am just, if currently you can see in output root there is no field. In output root I am creating a field called xmlnsc dot result dot second year dot student. This field I am creating, and the same field from I am just selecting from the input root from here. So if you go here, currently there is 4, but I will be selecting only that having the second year. So if I will show you, okay, currently you can see only one field has been created for now, because it is executing the code. Okay, it has been executed, and you can see the all the two has been came here, first second year and second year. Okay, and same thing we are going to get in the output. You can see the same thing in output. You can see the tag as result, under result we have the student, under that we have the two student, first student and the second student, and both are for the second year. So what it is doing, again if I want to explain you what it is doing, it is checking the condition. If it is checking the condition from the this tree, whether the if any class tag is second year, if class tag is second year, then it means the field exists. So exist condition is it is checking whether the record exists or not. You can see there are two record exist for this class is equal to second year, so it is satisfying the condition, and this line is going to execute. And further in this line, what I am creating a field called result dot second year dot student. So you can see result dot second year dot student. Under student, I am just whatever the value present for the second year, you can see these two value, that is the first is the this one and the second is this one. These two value I am assigning against, against this student. So under this student you are going to see these two value. Under this student we are going to see these two value, that name class this and this. Okay, so that's the way we can use the exist condition. Okay, now let's see what if second year not exist. So what is going to happen? So let me again write here as a first year for the other conditions also. So now we don't have any second year in the list. Okay, so again let me clear the output queue, and let me just select the input message, just return to the queue. It came here, it will check the condition if in the input message second year will exist or not. In input message, if you see, let me make it here. Okay, in input message whether any second class is equal to second year exists, so it is not exist. So you can see from here also, if I will explain, rather than if I will, you can see here it is also first year, here it is also second year, first year and the first year. So if there is no second year exist, so it will not execute this line of code. Further it will check else if condition, if not exist the second year. So it will check whether if in the input message if second year will not exist. So you can see there is no second year, so it will execute this line of code. Okay, so if I will move further, you can see now else if condition checking. Now this condition satisfied, so it will directly came here, and currently you can see in the output there is nothing, but after executing this, you can see in output it printed like that, second year result dot status, second year result will be published soon. Okay, so in this way we can check the exist or not exist. Okay, and if I will further move forward, and you can see it's the same in the output message. You can see second year result will be published soon, and keep checking the college website, the same message published here. Okay, so if I will again summarize the existing, because it is very important. This is mainly used for the table. So consider here a situation, instead of thinking like the XML message, consider like a situation where we have a table name result and we have a column named class. We are checking if class contain any value, class column contain any value as a second year. If it will contain any value as a second year, any row as a second year. If in column class we will get any row that having value as a second year, it means there is some value exist. It can be one value or many value. So this condition will be satisfied and it will return true. Further, what I am doing here, further what I am doing here, I am consolidating, I am combining all the result of second year student and just sending to the output by creating some field, that result dot status, result dot second year dot student. Okay, if this condition is not satisfying and we are not getting any class column that contain any row as a second year, then we are going to else if condition. Further I am checking if a column does not exist any second year. So I am checking if a column value does not exist second year. If the second year will be not exist in any column value, then I will be just printing the some hard code value. So exist is used to check whether a row exists in the table or not. If exist, it will return true. If it will not exist, it will return false. So and we have already see how basically if second year was existing, then we are getting the combination of all the uh, tree in output, and if it was not existing, then we are getting the hard coding value that I explained you using this example. Okay, now let me comment this and let's move forward. Okay, now let's come to the singular operator. Okay, this is also important operator, and this is you can say the brother of the, if I say the brother of exist operator. So again, let me do first thing, build and save the var file. I will explain later. Okay, so I build, save the bar file, I deployed the bar file. Now let's me explain the singular operator. The operator singular returns a boolean value true if the list has exactly one element, otherwise it returns false. Okay, so it basically checks if the table contain only one value. If it contain only one value, then it will return as a true. If it will contain only one more than one element, then it will return false. This operator is useful in a scenario where you find to where you need to ensure that the list contains only a single item, which can be crucial for certain type of data processing and validation. So you know the things. Suppose many times we need to check whether it contain only one element. If contain one more than one element, that can be a problem. Okay, so in that case we can use a singular operator. Okay, so if I will again summarize the thing, singular operator is returns the boolean true and false. If the list contain exactly one element, then it will return as a true, and if contain more than one element, then it will return as a false. Okay, so if I will go to the further syntax is similar to the exist. Here instead of exist, we are using as a singular, and further we are checking whether it is exist or not. If it is exist only, if it exists only one record, then it will print it will this hard coding value. If it will exist more than thing, then it will print like this. Okay, so what I am checking here, selecting R from the input root student. So I am just selecting, I am checking if a student contain more. See, you can see currently here 4 student, so it will be not satisfying this condition. If there will be only one student tag present in the message, then it will satisfy the condition. So let me show you. Okay, currently you can see that there are 4 students, first student, second, third, and the fourth. There are 4 student record present. There are 4 record, first element, second element, third element, 4 element. There are 4 element present. Okay, currently, and as per the singular operation, if input message contain more than one record, more than one element, then it will return false. So if it will return false, then it will go inside the else block, because if this, then return true, else this. Okay, so let me hit the flow. Let me select the message. Okay, selected the message. Let me write to the queue, it into queue. It came here, declared the INF. It came here. It will check first if singular operator and the list expression. In list expression, it is checking select R from the input root dot se dot student dot student dot student detail dot student as R. So it is checking if the student tag checking. So it is 1 2 3 4. So you can see there are 4 student element present with this record. When it is searching this record, it is getting there are 4 student element. So as per the singular operation, if it contain more than one element, so it will return false. So it will not go inside this condition and it will directly came to this condition. You can see directly it came here, it does not gone to here. Okay, and in you can see in it, I further if I will execute this line, it output you will get as a same thing that I am having understand and the count, same thing I am printing in output, more than one student in the list, right? And if I will further move forward, and if I will browse the queue, you can see more than one student. Okay, so let me try to remove the list. Okay, see if I will remove some student list. Okay, now you can see currently only one we have only one record. Okay, and under student detail only we have the only one record as a student. Okay, now let me again hit the message with the one record and let's see what is happening. So this time I am just writing with the only one record of a student. Okay, so let me write the message. I just written the message, it came here, go inside the compute node, it declared here, it came here, it will check singular with the singular operator. If this contain only one record, then it will execute this, else this. So you can see what is checking select R from the input root dot you can see currently if a student contain only one record, you can see currently one record is present, only one student record is present, right, containing this much value. Okay, so it is content it currently you can see also here there is only one record present for the student. Okay, so only one element is present. So if there is only one element, then it will execute this, else execute this. Okay, so if I will move further, you can see it came here, and currently in output you can see there is no tree. But if I will execute this line, you can see student dot count only one student in the list. Okay, and same thing we are going to see in the output queue. So if I will browse this queue, you can see only one list student. Okay, so if I will further, I will take 2 minutes to summarize the difference between exist and the singular. Exist check from the table whether one or row more record exist or not. If it exists, it will return true. If it will not exist, then it will return false. Singular operator do similar type of works, but different thing is that singular operator check if it whether it exists only one element or not. If it returns only one element or only one record, then it will return true. If it will exist more than one element or more than one record, then it will return false. Okay, so I hope you have understand the singular operator. Now let's move quickly to the other operators also. So let's move to the in operator. Let me uncomment this thing, and let me first do my one task, that build and save and deploy, then I will explain. Okay, so build and saved and deployed. Okay, okay, done. Now let's understand the in operator. Syntax for the in is value in and the value 1, value 2, value 3, dot dot dot. Okay. This operator is used to check whether a value is equal to one of the value in the list and return a boolean value. Okay. So this also returns the boolean true and false. Okay. And it returns the, it will basically checks if a value is equal to one of the value in the list. Okay. So if I will explain this thing, suppose there is a value here written as a, suppose there is a this value, if this value find in this list, then it will return true. If this value will not find in this list, then it will return false. Okay, that's the thing you need to remember. Okay, so in operator in work is work in such a way, if the value before in will exist from the list, then it will return true. If value before in will not exist this in this list, then it will return false. Now let's understand the example. Here I just made some complex example, but let's try to understand. Okay, here I'm just doing two operations. First is the if and else if block, and if where further if and else if blocks, and I am segregating this with the case statement, where when case applying and else can case applying. Okay, so first I am checking if unref dot class is not null, when this class value is not null. Okay, so if this is not null coming, then it will execute to this block. If the class is coming as a null, then it will check this condition. Okay, so if so this is a small code I have written, where a student can check what is their college timing and what is in which building of the college they need to go. Okay, suppose a student after the semester break, a student came to their college, or they want to know what is their timing, because timing can be changed between the summer season and the morning season, summer season and the winter season, because right. So according to season, the timing for the college has been changed, and the building, apart from that, the building also changed. Okay, so a student want to check what is their timing and in which building block they need to go to the college. So this is the small case code I have created. A student, if a student will check, if a student will be checking with their, if a student will be checking with their class, then suppose there will be two type of student. One student can check with their class, and other student can check with their branch. So if a student will be check with their class, then this code will apply, and if a student will check with their branch, then this code will apply. So what I am writing here, first I am checking if a student is providing class or not. If a student is providing the class value, if the student is providing the class value, then in that case I am just checking whether the class contain any of this value. If the class is second year, third year and fourth year, then in output route we are creating a field called student, college timing and building block, building number. The college timing is printing as a afternoon shift, college will start at 12 noon, and the building block is block A. Else if the class is not second year, third year, fourth year, it means class is first year, then it will be a morning shift, and the building number is block B. if a student is not providing their class, okay, so in that case what is happening? In that case we are checking branch. If branch is electrical, civil or mechanical, that is the core branch, then they will go to the afternoon shift and block will be block A. Else if branch is not in electrical, civil, mechanical, then it will be the afternoon shift and block will be block B. Okay, so if I will say here, here how basically in works, you can see same syntax I am applying. This is the value, after that we have the in, and here are the values. Same thing you can written here, value, in, and the list. Similarly, if you see here, value, not in, and the list. Similarly here the value, in, and the list. Value, not in, and the list. So if this value is present in this list, then it will return true. If this value will not present in this list, then it will return true, because here I am using not in, but not present in. You can see not in is, in means present, not in means not present. So if this value is not present in this, then it will print. Similarly, if this value is present in this, then it will print this. If this value is not present in this, then it will print like this. Okay, so that's about in. So in basically checks if this value is present in this list, then it will return true. If this value is not present in this, then it will return false. Okay, so let me now execute the code and show you. Okay, before that, either you can remove the these all tag, that's not mandatory, or you can keep it. Okay, so that's not a problem. Okay, so because this name, roll number, and marks not required, only we need the branch and this thing. Okay, so we can keep or you can leave it. Okay, so for now left the default. Okay, so currently if you see, let me modify this branch as a second year. Okay, okay, and let me hit the flow. Okay, not in the input queue. Okay. So I have selected the class as the second year and the branch as a CSE. Okay, so because when the student is selecting as a class, so it does not, it will not check the branch. Okay, but you can ignore the branch, that's not a problem. Okay, so now I heated the flow, it came here, and okay, by mistake I printed to output. So I let me clear the view again, let me hit the flow. So I return to the flow, it came here. Let me go inside the compute node, declare the inref, and if you see here, currently in the inref we have the name, class, name, roll number, class, marks, and branch. But name, roll number, and the marks is not required, just you can ignore the thing. Focus on the class and the branch. So currently we have the class as the second year and the branch is the CSE. But here we are applying the case, and in the first case we are checking the class. So if inref.class is null, is the class is null? No, class is not null because class tag is present. So it will go inside this if block, not go inside this else block. Okay, so you can see it will check it checks if the class is null. If you can see the class is not null, so it came here. Further it will check if inref.class, you can see inref.class, that is the second year, lie inside this value. Okay, you can see it lie inside this value second year. So this line of code is going to execute, and we are going to see this in the output tree. Okay, so you can see it came, this executed, and in output root currently there is nothing, but after executing we see, you can see college timing and the building block executed as per this thing, afternoon shift and the block A. Okay, and the same thing we are going to see in the output. If I will see browse the queue, same thing we are going to see in the output, you can see. Okay, afternoon shift and the block A. Okay, now let's modify the condition. Now let's this time send the first year, and let's see what is happening. The class is the second class, let's class to second year, and what I am checking another condition. Okay, okay, class in, let me class second as a first year. Okay, okay, so and let me hit the flow. So I hit the flow, it came here, declare the inref. You can see currently first condition, it will check if class is not null. You can see class is not null, class tag is present, so it is not null. So this condition is satisfying, and it will go inside this if condition. Under it will execute the code under when condition. So this code is going to execute. Further it will, if I will, we can move forward, it will check if inref.class present inside this. So if you see inref.class is the first year, and this value first year does not lie from this list. Okay, so this, it will return false, and this will not going to execute. And further it will check the else if condition. Else if condition is saying that if inref.class not in this list. So you can see this condition satisfy, because inref.class is the first year, and that is not present in this list. So this line of code is going to execute. You can see directly it came here, and in output root you can see currently the field got created as a college timing. Once I will execute this, it will execute the building block. So you can see this time this code executed, and the block is the building block, and the morning shift printed in output. Okay, further if I will move forward, you can see the same thing printed in the output queue. Okay, now let me read the queue. Okay, now let me further go further. In this way you have seen how basically we can use the in operator. Okay, here we are using in operator to check if the class value lie between this with the help of in, and here we are checking if the class value not lying between this. Similarly, let's try with the this else condition. Okay, so again same thing, let me send this time the class tag as a null. So to send a class tag as a null, just delete this field. Okay, so I just deleted this field and just save the message, and let me hit the flow. So I just selected this student detail. You can see currently I am not sending any class, so it will be null, and I am sending the branch as a CSE. Okay, so this time it will print as per the branch. It came here, it will go inside the compute node, it will declare the inref. You can see currently inref having 4 field. So first condition, it will check if inref.class is not null. You can see currently inref dot class. Currently class tag is not present. It means it is null. If any field is not present, then it means it is null. So it is first condition is saying when this is not null, then this will execute, else this will execute. So you can see here inref.class is null. So this when is not going to execute, and it is going to execute the else block. So you can see it directly came here. It has not executed this thing. Okay. Further, it will check if branch inref.branch present in, what is inref.branch? Inref.branch is the CSC, is present in this list. So electrical, mechanical and civil, so it is not present in this list, so this is not going to execute. And it will check further else if condition, and it will check if the inref.branch is not present in this list. You can see electrical, mechanical, civil, from this list it will not present. So you can see CSC is the list that is not present here, so this line of code is going to execute. So you can see it will directly came here, it directly came here, and in output you can see the field has been created, college timing. Further I will execute, it will print as a building block, and you can see the same thing, the building block as a B and the college timing as a this printed. Okay, and same thing we are going to see in the output queue. Okay, so if I will browse the output queue, so you can see building block B and the college afternoon shift. Okay, now let's execute the last case, last condition where I am sending the branch as a electrical, so or any electrical, mechanical or civil, anything. Okay, so let me send the message. So I have selected the message, let me write the message. It came here, it declared the condition, it checked the case, when it will check whether a class is not null. You can see class is not null, a class is null, so this condition will not satisfy, it will directly came to else condition. So it directly came to else condition. It will check if inref.branch, so inref.branch, what is the value? That is electrical, lying from this list. So yes, it is present in this list because electrical is this. Okay, so if this value present in this list, then it will return true and it will execute this line of code. Okay, so you can see inref.branch is the electrical that is present in this list, so this time this line of code is going to execute. So you can see this executed and this executed, and same thing we are going to see in the output, that college time afternoon shift and the block A. Okay, so I just written wrong thing here. I need to write a for the morning shift, but anyway just consider the concept. Okay, in copy paste I've written the same thing. Okay, that's not a problem. Okay, just understand the concept. Okay, so same thing you are going to see in the, okay, same thing block A, same thing. Okay, right? So in this way we have seen how basically in operator works. Let me take one more time to summarize the in operator. So in operator we have learned how basically works. In operator, this is the syntax. It basically checks whether the value before in lying in this list, if it will lie, then it will return true. If this value will not lie in this list, then it will return false. Already it is written in definition also, if it is used to check a value is equal to one of the value in the list. A value is one of the value in the list. Okay, same thing I have checked here. Here I have checked the condition for the class, whether the class is lying from this list or not. Here I am checked the branch, whether branch this is lying in this list or not. If it was lying, then I was executing this condition, otherwise another condition. Similarly, if I was checking here it was lying is this condition, then it was satisfying this condition. Okay, so here we have checked not only in, we have see how basically not in also works. Okay, So in this way we have learned the in operator in the ESQL. Okay, not now let's quickly go to the other operator and just in the try to end the session. Okay, so let's go to the other condition, that is the is operator. Before explaining the is operator, let me build and save the bar file. Let me do first work, deploy the solution. Okay, now is operator, is or not, again is not. Okay, so either similarly not in or not in, like that. Similarly is or is not. Okay, syntax is like that: operand, is or is not. We can apply true, false, null, number, none, and unknown. Each operator is very much important. Okay, people mainly ignore the each operator, but it is important when we are talking about the null. If you remember the thing, if you remember the thing, suppose I want to check whether class tag is null or not. So use to whether an expression has returned a special value. The main purpose of each operator is to test whether a value is null. You can use the comparison operator equal to test the null value. You cannot use the comparison operator null, because resulting of comparison operator will return null. If you remember, suppose here you can see currently class is not present. Okay, suppose I want to check a particular field inref.class is null or not. Okay, so if I will write like that, if I will write like that, if I will write like that, if set inref dot this is equal to null. So what will happen? What it will do? It will delete the class tag. So same thing it is saying here. You cannot use the comparison operator equal to test for a null value. Or if I will if I will try to compare with equal to, if inref this is equal to null, so it is again going to delete the tag class. Okay, that we have learned earlier. Okay, so directly assigning a null value to any field will delete the field. That's the important thing. So it will delete the field. Instead of comparing the field, it will delete the field. Okay, so how can we overcome this solution? So this solution can be overcome with the help of each operator. With the help of each is equal to each null, we can compare, we can check whether the particular field in the input message is null or null not. If that is null, then we can apply some condition. Okay, similarly here what I am checking, if inref.class is null, it means if somehow class tag in the input message is missing, then it will print some detail like that class detail is missing. Else if branch is not null, again I can apply not also, then it will, whatever the coming to input, just print to, it will send to output. Else it will print like that branch is missing. Okay, so let's see in the debug mode. Okay, so again let me send a message without a class and let me show you. I sent a message, it came here. I declare the inref with the reference variable. Okay, now let's understand the thing. Currently you can see under the inref we have the name, role, marks and branch. There is no field with class. It means class tag is missing. or in other word we can say that class field is null. Missing means null. Okay, so in other word we can say that class field is null. So if condition here it is checking if inref dot class is null, you can see inref dot class tag is not present, it means it is null. So then in that case it will satisfy this condition. In output root we will going to create a field student dot detail, and under detail we are going to write a class detail is missing. Okay, so you can see it will execute, it will came here, it will check the condition, and in output root it will print like that class detail is missing. Okay, and same thing we are going to see in the output queue. Okay, same thing you can see. Okay, so here we have checked how basically each working. Okay, we are applying each with null. Okay, now let's try to send the class and check the branch. Okay, so let me again switch back to class. Now it is actual message came. Now let me again hit the flow. So I just hit the flow, it came here, it go inside the compute node, declare the inref. Now you can see this time we have the name, role, class, marks and branch. It will check the condition if inref.class is null. No, it is not null, there is some value assigned to it class, so it will not execute this condition. Further it will check else if condition. In else if condition it will check if inref.branch is not null. So you can see inref.branch is not null, because that's correct, because in branch we have the value as a CSC which is not null. So this condition is satisfying because inref.branch, that is the CSC which is not null. Okay, so in this way we have seen how basically not also we can use is not. Okay, so here we are using is and here we are using is not. So both condition I just tried to explain you. Okay, so here we are checking if inref.branch that is CSC is not null, so that's condition is satisfying, so it will execute this line of code, and whatever the message in input we are going to get in the output. Okay, so you can see it just check, it will check the condition this one, and you can see in output same message we are seeing, and you can see the same. Right, now let's switch back to third condition. This condition we are sending the class but making branch as a missing. Okay, now let's save the message, and we are sending branch as a blank or null, sorry, not a blank, null. Okay, so just let me write the message. It came here, let's me go inside the compute node, declare the inref, and you can see currently under the inref we have the four field: name, role, class and the marks. Branch field is missing, so it means in other word we can say that branch field is null. So here first condition we will check if inref.class is null. So inref.class is null, so it is for false. So because inref class is not null, so it will not execute this line. Further it will check else if inref.branch is not null. So you can see currently inref.branch is null. So again this condition will also not satisfy. Further it will go to else condition and it will print that branch detail is missing in the output tree. Okay, output root. Okay, so so it will, you can see if I will execute further, you can see it. Okay, Okay, somehow debugger is not behaving properly. We are getting the same result, but somehow it is debugging is not happening properly. So you can see branch detail is missing, right? So let me do one thing. Let me try to uh, terminate debugger and switch back to the flow. Okay, but let me again show you. Okay, before doing this thing. Okay, so again let me hit the flow and okay, just clear the queue and right. I just written the it came here, it go inside and it came here. First it check whether the class is null, so class is not null, so it this condition will not satisfy. And first second, because it somehow it is coming wrong place, it should came to here directly, but we will see same thing in the output. You can see output is coming branch detail is missing, so it will check this condition, this condition is not satisfying, so it will directly came here and it will execute the line according to that. Okay, and same thing we are seeing in the output. Okay, so that's about the that is about what that is about each operator. So in each we can apply each or is not as per situation. We can write is true, is false, is null, is number, is none, num, is unknown. So this much, or apart from that there are few more of condition we can apply with is. Similarly with is not true, is not false, is not null, is not number, is not num, is not unknown. So this much of condition we can apply with the is. And the most important thing you need to remember for the is, the mostly we use each case with the null, because we can, if we apply directly equal to with any field with the null, then it will delete the fault, it will delete the field instead of comparing the field with the null value. So that's to overcome this issue, we have the each operator. Each operator basically checks whether a particular field is null or not. If it will be a null, then according to that we will apply some condition. If it will be not null, then again further we apply, according to that we will apply some other condition. Okay, so in this way we have seen the each operator, and the last and the operator is the like operator. Before that, let me just try to terminate the debugger and let me try to, actually I was experiencing some not a good behavior with the debugger. So what I did, I terminated the debugger and I again relaunched the debugger. Okay, because I was seeing some anomalous thing like that, it was not behaving properly. Okay, so what I did, I just terminated debugger and I was just relaunched the debugger because it was launched from the longer time, so that's the reason that it was creating a problem. Okay, so another what I did, we have covered the each operator. Now the last operator left is the like or not like operator. So I just uncommented this code and I just build and save the bar file and deploy the code. Okay, and let me explain the like operator. As name suggests, like or not like. Like means you are liking to someone and you are not liking to someone. Similar thing is applied here. It will check, syntax is that expression like or not like and the pattern. So it will check whether particular this expression is like this pattern or not, or this particular expression is not like this pattern or not. Okay, so that's the thing. Use the like operator to search for the string that matches a certain pattern. Return boolean. Here in like, percentage means match zero or more character. If I am writing single thing like that, it means matches exactly one character. Okay, so if here let's see what actually I'm checking. Here I'm checking if the class likes percentage here. It means What is mean by percentage here? Let me tell you. First, it is better to explain you. Okay. Percentage here means whatever the percentage tell about that. Percentage tells match zero or more character. So if I will apply before year percentage, so it will anything before year it will match. If I will apply, so if I will here add first year, second year, third year, fourth year, fifth year, anything it will accept. And if I will write like that, if I will write like that year percentage, so it mean like that anything after year is acceptable, but the first field should be year, and after that anything can be present. And before year percentage means like that, here percentage means like that last field should be year, but before that anything can be acceptable. So it will match any character before year, but the last should be year. And if I will apply like that, so before it will match any character before year, it will match any character after year, but there should be a field that name as a year. So percentage tells that the it can be match zero or more character. Now let's understand the second thing. What is mean by this? So if I will write like that this E, so it means like that the field should be ending with E, and before that there should be a one field, but it can be any field. So if there should be a one character, so there should be one character can be possible, but it can be any character. If I will write two times like that, okay, so you can see there is currently a space of two, one first character and the second character. So there can be a two character possible here, but it can be any character. So if I will write like that, suppose, okay, so it means that the first character should be C, last character should be E, and in between it can be anything. If I will write like that E F, okay, so it can be like that first character should be C, after that any one character can be possible, further after that E is required, further after that any two character can be possible, and further it should be ending with F. So it can be like that. Let me take example. It can be like that C A E I T F. So here you can see A is any character. You can see take any between A to Z. Further E is mandatory. Further from I and T you can take any letter between A to Z. So it basically tells one underscore tells you that one character. The same thing I have written here. He matches exactly one character. You can see I written here for this one matches exactly one character. So that's the concept you need to remember. Okay. So I'm just spending some more time on explaining this thing. That's the thing you need to remember. For this, you can understand like that. Suppose anything like that before that, it will be acceptable. But after that, in between, there should be a year, and anything after that, it should be acceptable. Okay. So before year, anything can be acceptable. It can be a one character or it can be a many character, and in between after that, year is required, and after year, anything can be acceptable, any character. It cannot be one character, it can be a many character. Okay, one character or many character, that's not a problem. Okay, so that's the thing you need to remember how basically percentage, what's the meaning of percentage and what's the meaning of this underscore. Okay, so now let's understand our real example. So in our example, what I'm checking, if inref dot class, where is the class? So I have the class. Okay, let me do some jet. I want to modify my, okay, now that's actual message. Okay, so now if inref dot class, okay, like percentage year, so you can see currently it is like percentage year, anything before year it will work. Okay, so currently we have the first year, so first, second, third, anything work, then it will go inside the further this if block. And if further I'm checking if inref dot branch is like this, is like this means is like this, is like this. So if you see currently I have the only 5 branch, so what are the condition will satisfy for this? So you can see, so if I will write like that, so it should be ending letter should be e, and before that one letter should be present, but it can be any. So from our branch you can see currently we have the CSE, IT, electrical and the mechanical and civil. Okay, so there are 4 branch that is ending with e, this one, this one, this one and this one. But there are these 3 only possible that having the only one letter before that. So it can be a this 3 letter, this 3 branch can be a this thing. So if I will write like that for this one, so it can be a this thing, because you can see for this all the ending letter is e and there is only one letter present before that, and it can be any, that's not a problem, in letter between a to z. But for this CSE ending letter e, but before that there are 2 letter present, so that's not satisfying the case. So for this case we will be checking if the branch is ending with e and before that there will be only one letter, then it will create a field dot student dot detail. Under that we will be printing like that student has opted the core branch of engineering, because you can see the branch is electrical, mechanical and civil is core branch engineering, and the CSE and IT is the non-core branch that I told you in the beginning. Okay, similarly if I will checking another condition, if inref dot branch not like e, so if it will be not like this condition, then apart from that it will be like this and this, then it will print that the student has opted non-core branch of engineering. Okay, so now let me hit the flow and show you. Okay, so let me first, you can see first I have selected the branch as a CSE, which is the non-core branch. So let me check, let me do. Okay, so let me hit the flow. So let me write to queue, it returned to queue, it came here. Let me go inside the compute node, declare the inref as a reference variable. You can declare it here. Currently if I am checking if inref dot class like percentage year, you can see year should be ending and before that it should be anything present. So you can see there before that first present, that's fine. So it will further go inside this if block. So it further came here, this if block. Further it will check if inref dot branch is like underscore e. So you can see currently it means that one letter ending word should be e, but before that only one letter is possible. But here you can see before e there is a two letter, so it will not satisfy this condition. So this is not going to execute, and it will be going to execute the else block. So you can see the else block has been executed, else if, because here in else if it is checking the condition that if inref.branch, if inref.branch is not like this, so not like this, not like the word that ending with e and before that only one letter possible. You can see here it is two letters, so that's satisfying the condition. And here we will get in output as a student has opted the non-core branch. You can see same, a student has opted the non-core branch of engineering. Okay, now let's try the another condition where I am just sending the core branch. Suppose I am sending here as a, instead of CSE I am using a electrical or mechanical. Okay, so let me hit the flow. So just hit the flow, it came here, declare the inref. You can see currently I have the branch as the mechanical engineering and the class as the first year. So first it will check a class percentage first year. Okay, so it will satisfying the condition, so it will go inside the first if block. Further it will check if the branch is like this, so it is also satisfying condition. You can see ending letter is e and before that one letter possible, so before that only one letter m is present, so it will satisfy condition. And this time this block is going to execute and this line of code is going to execute. Okay, so you can see this line of code executed, and this time in output we will be going to see a student has opted the core branch of engineering. Okay, so you can see a student has opted the core branch of engineering. Okay, now let me, this thing happen, now let me show you last thing. Suppose in percentage if I will write like that here, in instead of writing, if because percentage year, so it should be work anything, but if I will write here like that, suppose first year branch. Okay, so is this going to work? No, it is not going to work. Let me show you. So if I will select the student detail, if I will write the queue, you can see it came here. Just go inside debug mode. You can see declare the inref. Currently in the inref we have the class and the marks. Branch is mechanical engineering, that's fine. Class is the first year branch. But if you see here, we are checking if inref.class, okay, like percentage year. It means that ending word should be year and before that anything can be possible. But here if you see ending word is not year, after that we have the branch also, so in that case it is not going to execute and the if block is going to terminated and we are going to get a blank message. You can see it got terminated, and if you see the output we are going to get a blank message, right? So in this way, if I will again further summarize the last case, that is the like, as name suggests, like or not like means if expression like this pattern then it will return true, if expression does not like this pattern it will return false. Okay, and we have the percentage means anything before a percent may matches with zero or more character, and with underscore is like that, with one underscore is like that one character and matches exactly one character, and two underscore matches exactly two characters. Similarly you can write for anything. Okay, that's fine. Okay, so in this way we have seen the like operator also. So for now we have what we have seen, in comparison operator we have seen the greater than, less than, greater than, equal to, less than, equal to, not equal to. These all operator we have seen to compare the field. Further we have seen the between operator to check further comparison also. Exist operator is used to check whether the any field exists from the table or not, any row exists in the table or not. Similarly, singular we use to check whether a particular one record exists or not. Similarly, case we have checked with the help of in or not, which we can check a particular value present from the list or not. If that will be present, then it will return true, otherwise it will return false. Similarly, each or not each we can assign some each true, each false, but it is most used for the null case. Similarly, with the like operator, we can apply the like condition like that, whether it is liking a particular pattern or not. If or it is that's the condition we're applying. Okay, so we have seen all the cases for the comparison operator. So I hope you have enjoyed the session. Again, if you have any doubt, any question, then you can reach out to me over the mail mylearnandpassofficial@gmail.com. Thank you all.